get started. We're back with another episode.
Do I have to reveal anything about myself, or is this? We don't do that on Ask.
Totally up to you.
I think people know plenty at this point.
Well, we're back with another episode of Ask a Grad Student. These are fun ones.
These are very fun ones.
So
back on Purdue's campus.
Yeah.
Yeah.
We're back with Grant and Jesse. So we're going to talk about some cool research that they're doing. They're weed science students, and they're doing some pretty cool research. And so I'll let them both introduce themselves, and we can go into each of the research, individually. And then it sounds like they got some overlapping, some areas that overlap kind of within their research. So, Jesse, we'll start with you. Tell us a little bit about yourself, where you're from, how you ended up at Purdue.
Yes, good afternoon. My name is Jessie Lewis. I'm originally from Metropolis, Illinois. I got my bachelor's at Murray State University in Murray, Kentucky, where I majored in agronomy with a minor in unmanned aerial systems.
Oh, cool.
And then pretty well had an internship that kind of guided my interest in weed science, and reached out to Dr. Young here at Purdue, and the door was open for me to do some work up here, and so I took that opportunity.
That's pretty cool. No, happy to have you on the show, and look forward to hearing about your research and learning from what you know. Grant?
You said you're from Illinois?
Yes.
You have almost a Kentucky draw.
Yes, I am if I had a good arm, I could throw a rock into Kentucky.
Okay.
Yep.
I was going to say I don't know where Metropolis, Illinois is, but you sound like you're from Bourbon country.
Pretty well.
Grant, tell us a little bit about yourself, where you're from, how you ended up at Purdue.
Yeah, so my name's Grant Isaacs. I'm originally from northern suburbs of Chicago. So decided to go down to Southern Illinois University, Carbondale for my undergrad. I was more into horticulture and kind of greenhouse management. But I started working for the weed science lab down there under Dr. Carla Gage. And that's kind of where I discovered my love for, weed science, killing weeds, herbicides, all-encompassing weed science. And after a few internships there, I went and got an industry internship, and it really solidified my what I wanted to do. So I just reached out to Dr. Young and started a master's program here in 2023, and my project really focuses on herbicide interactions between pyridate and HPPD inhibitors.
Yeah, that's pretty cool.
When you said you did you say an internship in industry?
Yes,
Okay.
yes.
Yeah. So what was it that pointed you back? Said, okay, I want to go learn more. What drove that?
Yeah. So I think so I had an internship, both academia and industry. Academia, I really found. I didn't really know what weed science was. I kind of just got into agriculture. I needed an internship for the summer, honestly. But then, working around equipment, working with different chemistries that, the goal is to kill weeds and, kill plants versus trying to make everything thrive.
Seems much more challenging, doesn't it?
Oh, yeah, yeah. And then, I wanted to venture out, get more into industry, see what the two sides were. And I really liked the industry side of things. I liked finding new chemistry, working with newer chemistries and different products that actually do help farmers out. But then coming into grad school, it that's really what made me want to start grad school and get into that higher level of education to actually get, have more of a say in industry and do more in industry.
Yeah, really understand how to kill weeds.
Yeah, exactly.
Well, Jesse, let's start with you. You're doing some pretty cool research, and we got two different areas we'll touch on with you. Tell us about some of the known issues with water hemp resistance. You got your target site and metabolic resistance, and then how your research kind of ties into that.
Yeah, so that's kind of a broad topic to start on, but right now for water hemp resistance, we're up to 7 modes of action that we're resistant on, and there's also multiple resistant populations out there as well. But starting off with a little bit of like the history, so we started getting resistance in water hemp out the 1990s with some of our group 2s, group 5s, and then eventually like the group 14s, and most of that was target site resistance, probably because that's what we were actually able to detect at that point. Then glyphosate came out And we really had most of those populations, wouldn't really say go away, but we were able to take care of them because glyphosate was so effective. Then eventually, between about 2004 and on, we started to have glyphosate resistance come about, and that was also a target site resistance through an increased gene expression. And then about that time, too, we were having group 27 resistance emerge, as well as a new form of atrazine resistance through metabolism. So that's where we started to have more talk about metabolism-based non-target site resistance was about that time, and that's pretty well been where a lot of our research is focusing today and what we're seeing the most problems with.
Are you sure you don't have your PhD already?
So tell us about your research looking at developing a rapid assay.
Yes, so in that specific portion of my resistance, that specific portion of my project, we are looking at developing a rapid assay. That way we can standardize testing across universities. So this is through actually what's called the Herman Project, which is a multi-regional project that is funded by the Soybean Checkoff. So portions of the North Central and the Southern Soybean Research Programs fund this, and the purpose of it is to actually connect researchers throughout these universities and share our knowledge on herbicide resistance in problematic weeds and soybeans, as well as developing new resistance testing methods and then sharing those with our growers and our findings and what management tactics that we are seeing that's going to be most effective. So my specific project, so there's lots that are encompassed in this Herman project as a whole, but my specific focus is with water hemp resistance, specifically a non-target site. So we're looking at atrazine, group 4, group 14, as well as group 10. So some of these, especially like group 10, we don't actually have known resistance to it yet, so there is no assays developed for it. So we are trying to develop assays for non-target site resistance because target site resistance is pretty easy to detect. Most of the time it's a high-level resistance, so it kind of screams in your face. But we will usually just take a tissue sample from the field or grow it out in the greenhouse and then go through and do PCR and lab assays and look for if a mutation was present. So for target site resistance, it's pretty well just a mutation in that gene or the receptor where the herbicide binds in the plant. And so that mutation is there, it isn't. So it's kind of like a light switch. And that's why that level of resistance is so high. But for non-target site resistance, it's kind of like a dimmer switch. You can have still low levels of resistance present and you not know it. So that is why we are trying to develop rapid assays to see if we can detect that non-target site resistance before it's a high level that we would see with target site resistance. Because again, to explain, target site resistance is usually metabolism based, so there's a functional group that's changed or it gets sequestered into the vacuole of the plant or a few other options there, but it can be a low level of resistance. So we want to be able to see if we can find an assay that can even detect that low level resistance because for target site resistance, we can pretty well do that just through our PCR.
Yeah, man, that's pretty cool stuff. Thinking about you all focused on non-target site resistance. Is this something that maybe have some of the technology or not? I'm not over familiar with what we have in terms of assays. I'm used to the old litmus paper tests, testing for traits and some of that stuff. Is this something you think you can maybe expand into as we have metabolic resistance, or even expand into some target site detection, maybe where we don't have it? Or is this specific to, these assays that you're creating, is this specific to non-target site resistance?
So it could still detect target site resistance.
Okay.
And again, this is all still being developed. We're still in the very early on and doing preliminary work in it. But we have to develop a rapid assay that is specific for atrazine non-target target site resistance in water hemp,
Okay,
as well as like PPO resistance in water hemp. So each assay is specific for that herbicide and that weed, but it should be able to encompass both non-target site and target site. That is something though that we are still working on to make sure that we can detect both.
Gotcha.
Does the developmental stage of the water hemp impact your ability to find that resistance?
So we haven't got that far in our research, but it is plausible to conclude that any like live tissue, we should be able to detect it in. So if we're able to have like some fresh green tissue that's newly emerging from the meristem, we should be able to detect it.
Gotcha. As Jesse, as you continue to learn about some of these resistance issues in water hemp and obviously Palmer, is there something that kind of stands out to you as a grad student that really made it hit home in how serious this problem is in terms of weed resistance? Is there one thing you're just like, wow, man, knowing that, understanding that really kind of changed the way I think about resistance with water hemp and Palmer?
So I wouldn't say there was like really one thing that changed like my outlook on it, but most definitely as I start to see a lot of our widely used herbicides, especially 2,4-D, dicamba, glufosinate, start to break, and seeing growers have issues with that, it's really disheartening and for sure drives my love to research in this area and make sure that I am finding ways that we can help growers.
I asked Grant, I didn't ask you, what drives this passion? I mean, you're brilliant, and it's super fun to hear you talk about this. And we talk about some of the fun of getting to do this podcast is we get to be near passionate people. You're clearly very passionate about this. What drives that?
Absolutely the growers. Yeah. My whole purpose of being in grad school, my whole purpose of my research, everything is to make myself a better resource for growers when I'm out of here. I want to make sure that I'm given the best recommendations I can, and the truest recommendations that I can based off of the research that we're doing currently. So it really is just making sure that growers have access to the what can just make them more efficient and the best growers they can be. Yeah.
Grant, let's talk about some of your research.
Before we go to Grant, I want to just say I'm super impressed. And we both have the opportunity. We get to talk to a lot of groups. I am super appreciative of your passion because we encourage when we talk to, we're going to sound old here.
We are old curmudgeons.
When we talk to young people, our encouragement is find something that you're passionate about, because every one of the professors that we've had the opportunity to interview while we've been on campus, the absolute consistent theme is they have deep passion, and I think that's the only way you can sustain a career. And knowing that your desire is to help people be better growers and control weeds better, I'm just super appreciative of that, and it's encouraging because I think there are a lot of people that aren't passionate about what they do, and then the results lack enthusiasm and lack creativity. So congratulations and thank you.
Thank you.
Yeah, you found your passion in life way earlier than I did. I can only imagine. I can only imagine where you'll be in 15 years compared to where. I mean, it's impressive. Your knowledge speaks
I would tell
for
some
itself.
stories about Andrew when he was your age, but that might not be best recorded.
Grant, moving forward, tell us about your research. You're doing some really cool stuff too. Looking at some of the interactions between this HPPDs and photosystem inhibitors. Talk to me about some of this research, why you're looking at it and what you're doing.
Yeah, so my project focuses, like you said, PS2 inhibitors and HPPD, and trying to see their interaction when they combine with one another. What I'm really looking into is the active ingredient pyridate, which is sold under the trade name Tough. And that's a group 6 photosystem 2 inhibitor that binds to histidine, the amino acid histidine 215. And this is different than atrazine, which is widely used, has been around for a long time. And atrazine binds to serine 264. And there's a bunch of research out there that documents this synergy, how these two herbicides complement one another to increase control on weeds. But we're wondering how this herbicide, or if this synergy translates to group 6 herbicides, pyridate, and also looking for that PS2 alternative to atrazine due to widespread resistance to atrazine and other environmental concerns, with the atrazine restricted use areas due to groundwater contamination, all that sort of deal.
So pyridate's really this new active that you're looking at, because I mean we've never really, have we ever used a group 6 here in the U.S.?
Yeah. Oh yeah.
Which group 6 are we commonly using?
So bentazone is one of them.
Yeah.
Bromoxynil, which is Bucktrill.
Oh geez,
which
heard
is
of Bucktrill
old
in a while.
chemistry. And
I remember my dad talking about Bucktrill.
Yeah, but pyridate, I wouldn't say it's a new active. It was introduced in the 70s. I think Syngenta had it out as a trade name Lentigran.
Okay.
But it's really reintroduced into the market. And we're really it's a contact herbicide, so it doesn't have much systemic activity. And in my opinion, I wouldn't say that it's really a sole product to use, but through best management practices, you really shouldn't be using just a single mode of action anymore, right?
Yeah.
So yeah, but we're looking more on how this group 6 interacts with the HPPDs, tembotrione and mesotrione.
Yeah, man, that's interesting. So why? I mean, what's the, why look at these HPPDs in photosystem 2? What is there, going back in the literature, is there a relationship between or synergism with these actives in these different groups?
Yes.
Is that kind of why you're looking at that now?
Yeah, so previous research looking at the group 5 photosystem 2 inhibitors and its synergy with the HPPDs, and they are along, they're different mode of actions, but they both follow the same biochemical pathway in a way. But using these, I guess it increases your, you want to combine two herbicides that work with one another. You don't want to add multiple things to the tank that are going to antagonize weed control, right? Yeah. So using both of them ultimately helps growers get a better kill on their weeds, improves resistance, best management practices, trying to mitigate the evolution of herbicide resistance by using multiple active ingredients. But the synergy, you strive to get that synergy within herbicide combinations. And most of the research out there, most herbicide combinations are actually antagonistic, looking at, all the different mode of action groups. But both the photosystem 2 and the HPPD are linked with one another, so it does provide an increase in control compared to each herbicide applied individually.
Yeah. No, this is good. And I mean, it's probably more foliar, but I mean, at a time where group 27s are becoming a little bit less, losing efficacy in corn, I'm guessing this would be a residual product you would add in, or is it foliar?
So pyridate is strictly foliar. It doesn't have residual activity. So the main focus is looking for that atrazine alternative for foliar control. Now, I would say that you are losing more residual control because you're compared to atrazine. But then again, if atrazine isn't working, then it's kind of
we're giving it up anyway.
Yeah, exactly. Yeah. Now, HPPD resistance and less activity from HPPDs, that's kind of hard to swallow, I would say, but combining these two herbicides, you are getting way greater control. I can't say that on a HPPD resistant species, but as far as an atrazine resistant population, then definitely see an increase.
That's good info. Yeah. That's good info for sure. Thinking about some of your research too, looking at the adjuvants you use. Talk to me about that. What did you choose? What did you use, and why?
Yeah, so for my research, we use 1% volume by volume of the crop oil concentrate. The main reason we chose it is because pyridate is a very lipophilic herbicide, so it's a very oily herbicide. So we needed to add an oily adjuvant in there to match the spray carrier to the herbicide for better compatibility. But the crop oil concentrate also increases absorption into the plant and increases efficacy ultimately.
Oh, that's good. I think the more we have all these conversations around, applications of herbicides that work, don't work. A lot of times it comes down to, hey, what adjuvant did you use? What were your other, are you trying to pre-mix some other products, make your own formulation?
Right.
Are you throwing in some other products to maybe help your corn or soybean plant, grow better, increase photosynthesis? And some of these things, I think there's more antagonism going on than what we. And I know one of the conversations I forgot to have with Tommy is just the importance of water pH. And I think there's just a lot of things that maybe we don't typically think of impacting the efficacy of our herbicides, but something as little as your adjuvants used. There's a lot more to it than what I think we give it credit for.
When you're looking at the COC, are you doing any variable rate to look at penetration if you're primarily foliar? I know we can really heat those mixes up sometimes for penetration. Are you doing any of that?
Are you saying variable rate with the adjuvant solely?
Yeah, just increasing the adjuvant load for weed penetration.
Right. No, none of my research is looking at that kind of variable rate with the adjuvant.
Yeah.
But most of it, if we are variable rates, it's looking at two different rates of the HPPD herbicide. But that mostly is kind of trying to bring out that synergistic interaction, whether there is one or not. Which,
with all the Group 27s that we have access to, do you see one having more of a synergism with pyridate?
Is synergism a word?
I'm going to make it a word.
You made that up.
I would say it's a word. I have this I've been having this battle with another grad student.
I don't
in our
think
writing,
that's a word.
Synergism. Yep, synergism.
I don't think that's a word.
Synergy. Antagonism.
If it's not, we're going to make sure it gets on the Webster Dictionary's new word.
That sounds. I'm just saying, you two are both way smarter than me 1,000 times, but I'm not convinced that that's a word.
Synergism.
Yeah,
but I wouldn't. So you asked the different HPPDs, what would draw out more of the synergy. I don't. So my research is mainly just looking at mesotrione and tembotrione, so just the triketone herbicides. Now, if we incorporate some of the others, or looked at some of the others, I don't know if it would. You would see more synergy between the herbicide combinations. I would think that since it's the same mode of action, same site of action, you would see just as good of efficacy from these the herbicide combinations, whether you're using isoxaflutol or maybe bicyclopyrone, but topramazole, topirolate, definitely.
Yeah. No, this is really cool research, and again, at a time where I feel like we need as many tools in the toolbox as we can have. I think this is pretty cool research. Jesse, Grant, coming into this, you guys kind of mentioned you have some of your research overlaps. Tell me about that. Where's it overlap? Kind of where are you guys kind of combining forces to think about how to manage weeds, kill weeds?
Yes. So another project that I have is actually working with atrazine and atrazine resistance and understanding the spread of atrazine resistance throughout the state of Indiana in problematic populations and which mechanisms of resistance are present. So we actually did a greenhouse trial this spring where we tested 60 problematic populations that had showed reduced efficacy from PPOs as well as 2,4-D and dicamba within the field and the greenhouse. So we screened all 60 populations and actually seen that all 60 had reduced efficacy from atrazine. And so that's where the atrazine portion is where we start to overlap. We also do research at the same field site where I had to dial in on which resistance mechanism was present. So to go back to those 60 populations, we actually found that non-target site was the most prevalent mechanism. There was no target site present. And the reason that is important for my research specifically is that we are looking at for target site resistance, in atrazine, it can also have resistance to metribuzin. So for non-target site resistance, it's only specific to atrazine. And so with that being said, that means that for most of these populations, metribuzin could still be a possibility to control them. And then at that field site that we share, we had also found that non-target site was the present mechanism there.
Right, and then so looking at the atrazine resistance, that's kind of where the PS2 inhibitor group 5 comes in, but it's trying to see whether pyridate, the group 6 herbicide, can replace atrazine in certain situations, and whether you're not dealing with the HPPD resistance, but going into whether that herbicide combination can overcome that herbicide resistance and control these biotypes.
Yeah, man, this is cool. Talk about having a tremendous. What a way to end feeling good about the next generation. We talked about these powerhouses here at Purdue, but man, it's shined through with the grad students that are following through. I don't think I could be more impressed listening to you two. No, this is cool information, and man, this whole weed resistance thing. We kind of joke with Tommy on here, going from years ago, almost joking around about not need weed scientists anymore because of glyphosate. Now we're in a situation where we need it more than ever.
Correct.
And handing off the baton to people like you, having like Bill Johnson retire and move on. It's pretty cool to see the next generation.
Other than the fact that they just randomly make up words, I'm super, super impressed. So
it's all about coining new vocab, bringing it into the literature now.
I can be whatever I want to be. Yeah. Super impressed with you guys. Appreciate you taking time to join us, and would ask you guys, we would love the opportunity to follow up with you guys.
Yeah, definitely.
Maybe at the end of next year, a little bit, find out what you guys learned throughout the growing season, and super appreciate your hard work. Best of luck.
Thank you. Appreciate having us on.
Yeah, thank you both.
Yep, thank you.
Introduce yourself and tell us about what you're doing here.
Okay, so my name is Annalise. I am a second-year master's student, and I'm working with Dr. Castile lab. I'm working with soybean extension, and my project is with soybean inoculation and sulfur treatments, which is the focus of Dr. Castile lab, mostly sulfur work.
Well, that's pretty cool. We just got done. We talked to Sean on his interview, and we talked about some of these interactions with the Brady rhizobia, sulfur obviously we touched on, so it's a pretty important subject. Man, what do you say, a 12 to 20 bushel response with sulfur?
Well, yeah, and in one instance 77 to 99 up the road, which it makes me think of like the diet commercials, like these results aren't typical, right? Like don't always assume you're going to get that, but
it gets interesting though, because you start looking at all the stuff that impacts that Brady rhizobia relationship, and then sulfur. It's if we keep having these extreme weather conditions, some of this stuff might be more the norm than not. Right? Because we know sulfur leaches, right? So
before we pick your brain on your research, though, I guess tell us, why are you here and what are you passionate about?
I like that.
Okay, so I'm from Brazil, and
we couldn't tell.
And I'm from a family of farmers. Okay. So since I was a kid, I am used to the farm environment. So I did my bachelor in Brazil in agronomy. And once I graduated, I wanted to go to graduate school, but I wanted to do it here. Because
how'd you pick Purdue?
Because I know it's one of the best in the United States and in the world. So I made some contact. I contacted Sean, and it worked.
That's pretty cool.
Yes.
I love that. So I know a little bit about Brazil, not a lot. So you're doing work in Brady rhizobia and sulfur and soybeans.
Yes.
So tell me a little bit about what's challenging about growing soybeans in Brazil.
Oh my gosh.
We were just talking about organic matters of 4 and 5. Really rich soil here. Talk about what is unique in Brazil.
Well, I would say that the weather is very different in Brazil than here. So we have way more diseases and weeds than you guys have in here. So we spend way much more money with fungicides and herbicides than you guys do here. Like for diseases in soybean, especially Agent Rust.
Oh yeah.
Sometimes we do 3 or 4 applications of fungicide.
Jeez.
And
Wow.
here I know that, especially here in Indiana, the farmers will do only 1 or 2.
Yeah.
So
Sometimes
this
it can be hard for one. It seems
yes. So my dad is a farmer, and when I tell him that here they do only 1, he's like, "Oh, I want to grow soybeans there."
Yeah, absolutely. When you're growing soybeans, so talk about maturity group in Brazil and your growing season.
Mm-hmm.
So so like here we're using primarily, I mean, I guess in this
Like a
part of the
3.
world, yeah,
Mhm.
2.5 to a
Mhm.
4.0. What maturity groups are
So
you using?
my state is very in the south, so we use maturity 5 to 6.
Wow.
And if you go like to central Brazil, like Mato Grosso, I don't know if you have heard of,
Mhm.
it's like 7, 8. Yes,
Wow.
yes,
Big difference.
Yeah.
yes, hmm
Out of our
Yeah.
depth a little bit.
It's a lot
Yes.
more heat over there.
Yeah.
yes,
Absolutely.
Mhm.
Yeah. So tell me about, I know you're kind of just getting into your research.
Mm-hmm.
What are you hoping to answer?
Well, I think that in Brazil, the biologicals are very common. Like people are using for more time than people here in the U.S. are using. And I know that inoculants have a great result in Brazil, but here, at least in my fields, I don't know if I can say that, but I'm not having differences in treatments.
Okay. Yeah.
So I don't know. This is something that I want to look more deeply because I don't have results from this season, but from last season, I almost didn't see any difference. But so far, for sure, there's a big difference.
Yeah.
Like almost 10 bushels.
So talk about, so when you say you weren't necessarily seeing a yield response, you're referring to inoculating with Brady rhizobia?
Yes.
Okay. And so what are you measuring anything other than yield when you do that?
Yes. We are going to do the ureides analysis,
Yeah.
but it's not done yet. We just sent it to the lab, so we have to wait for the results. But I think that will be a great parameter to.
Yeah. That'd be
to
good.
see.
Then you can actually look at there's more nitrogen in the plant. Right?
Yes,
Yeah.
exactly. And we did a lot of leaf sampling and our AIDS over, so we're gonna be able to see more differences.
Yeah. But you do see a response with sulfur. Sounds like
Yes,
it's pretty consistent.
Yes,
Yeah.
yes, that's true.
Yeah.
So talk about those trials if you would. What do those trials look like, and what have you seen for results?
So the trials without sulfur, they were light green. We can see, like we did some drone images and we could see the differences in color. And if you pull out a plant, you can see that there were not that many nodules the plots with sulfur had more nodules than the plots without sulfur. But if you compare like plots that were inoculated and plots that were not, basically we couldn't see that many differences. So the difference.
So more nodules when where you applied sulfur.
Yes.
That'll be interesting
Yes.
too, because you think about, is it the sulfur impacting yield?
Yes.
Is it the nitrogen from
Right.
from the rhizobia, or is it
Exactly.
the combination?
Yes,
right?
that's
that'd
what
be cool.
We are trying to answer with this research.
Yeah, that's cool.
Mm-hmm.
Well, no, I look forward to keeping in touch, and maybe I'm assuming just Purdue being Purdue, we'll be back here at some point. So I look forward to maybe interviewing you in a year or two when you got data.
Yes.
I've got kind of a exit question. So what is the best soybean yield you've had on your family farm in
That's a good
Brazil?
question. It's going to be kilograms per hectare,
Yes.
So.
Yeah,
Yes.
we won't even know what it means.
Yes.
You'll have to
Yeah.
Google the answer.
Actually, we don't say kilograms. We say, but it's more common saying like bags per hectare. So a bag of 60 kilos is what we measure.
Okay.
Yield.
Okay.
Yeah.
A bag of 60 kilos.
Yes. Yes. So
Test weight matters.
Yeah. That's,
we had, my dad was participating in a contest, like yield contest
that's
for
cool.
soybean. Yes. And I think he reached like 95 bags per hectare. Let me do the calculations.
That's cool.
This is, you talk about new things you're going to learn is how to.
5 times 60 would be like 5,700 kilos per hectare. Okay. And let me transform that for.
She can tell that our eyes are just
we're gonna have
over.
to do like a Hey Siri. Can you convert this for me?
Just a second. Bushels per acre.
It's cool to hear that there's still yield contests. I mean, that's something you think is like, I mean, that Americans do, but it's cool to hear that going on.
It would be like 85.
Okay.
It's not that much. Actually, if you compare to the yield that you have here.
Yeah. It'd be similar.
But
I mean, look at your.
This year, there's a lot of people that would be thrilled with 85 bushels.
It's probably a little bit different too, because you guys have multiple crops per year.
Yes.
Right, and so we're just pulling one off. You guys are pulling, right?
Yes. So in my family's farm, we have crops every year. Yeah. Like the whole year.
Yep.
The land is never without.
Yeah.
Yeah.
Well, I know very little, if anything, about growing crops in Brazil. Especially don't know anything about the kilograms per hectare. I just remember grad school in Haiti and having to do all that stuff, but just because it was so much over my head. But no, this is really good. Like I said, this is valuable research, and that Brady rhizobia conversation. I look forward to learning what you learn potentially, because that's something that, whether you're completely saturated soils, completely droughty soils, what's the impact on Brady rhizobia, that population, and is that something we need to worry about? Maybe not.
Yes.
We'll find out.
Absolutely.
Yeah.
So
thanks for taking time to join us today.
Thank you so much.
Yeah. So Darcy always causes anxiety when I talk to her. So Morgan, are you going to give me positive affirmation, everything's great, or am I going to leave here? Yeah. Wonderful.
We shall see.
Introduce yourself to our audience. Tell us a little bit about yourself.
Yeah, so I'm Morgan Goodnight. I'm a fourth-year PhD student with Darcy Talenko. I started working on tar spot initially, and then that kind of led me to venture down into white mold and red crown rotten soybeans, and so I just kind of enjoy it all.
You like finding problems. Where are you from, and what is your what has led you to a passion around agronomy?
And led to Purdue.
Yeah. So I actually grew up in the country in Oklahoma. I was in the country. I grew up raising hay and a whole bunch of farm animals, and I actually thought I wanted to be pre-med. So I went to the University of Missouri Columbia as a pre-med student. Quickly figured out med school was not my forte. Still wanted to do some more research, so I have my degree in undergrad in human biology. Oh, wow. So I thought, okay, biology research. Kind of stumbled upon an opening at the Plant Diagnostic Clinic. Fell in love with that. Met Caitlin Bissonette, who is Darcy's counterpart in Missouri, and fell in love with field crops and how that was such a neat, very different from like your lilac bush is sick. Here's a field crop, so you feel more impactful. It's really neat. And so she connected me with Darcy, and so came to Purdue. I actually started my master's, and we developed this really big irrigation project. I would be like here for 3 or 4 seasons. And I knew I wanted to do a PhD anyway, so I was like, what if I transition? And so here we are. Okay,
that's so cool. The key question, what is more difficult, human biology or crop physiology?
I think it depends. Like for plants, if you kill one, it's okay. Patience-wise, it's a little more struggle. But
little bit bigger of a penalty for screwing up in one market. Yeah.
Well, I'm looking forward to the conversation. Obviously, any Darcy trained student's going to be top notch, and I've been lucky enough to hear Morgan talk a couple times at some APS meetings and something else I can't remember, but. Really knowledgeable on tar spot. I haven't heard her talk about white mold yet, so maybe we'll get have a brief conversation around that. But she's doing some really cool research looking at resistance and resistant and susceptible hybrids and fungicide applications, as well as kind of looking at and trying to maybe dig a little deeper into the whole leaf wetness conversation. Let's talk about some of that research you're doing with resistant and susceptible hybrids, Morgan. Tell me about your hypothesis going into that, and then kind of what your protocol is to try and help answer this question.
Yeah, so we're looking at 2 different hybrids, known susceptible and then a known kind of moderately resistant. But the big question was, can we use resistance to either negate the use of a fungicide, or can we push off when maybe a fungicide might be needed? So we did, 2 different hybrids, and then we did different timings. So V10, VTR1, R2, R4, and then we actually utilized the tar spotter mobile application for risk prediction. So for the tar spotter application, if that risk got above, I think we used 35%, then we applied a fungicide and then monitored that throughout the season. And if it hit that risk at least 2 weeks after that fungicide application, then we applied again if it called for it. And so going out, doing our ratings, I could see a difference in resistance. Not looking at the treatment number, but walking into a plot, you start rating R3, and you could see a difference in the initial infections. The resistant hybrid really kept down those initial infections.
Yeah. What do you see for typical? I mean, thinking about a susceptible versus a resistant hybrid, what do you typically see in terms of differences in leaf severity?
Yeah, so like I said, initially we really see the difference. The hybrid that we used kind of started these initial infections, stopped those from progressing. You could see that hypersensitive response around those lesions. And then later on in the season, we kind of lose that resistance. You can see that tar spot kind of escalate as the season went on. Not as much and as steep as the susceptible hybrid, but you could definitely see it start taking off and lose that kind of resistance.
That's going to be some pretty cool info. Darcy brought up this whole R3 thing, and is there anything different going on? And again, Allison touched on it with the Southern Rust conversation. Is there something going on with that PAMP trigger immune, just that interaction with the pathogen and the host, in the host immune system, right? I don't think we know a whole lot about that.
Right.
It'd be kind of cool to try and help answer and figure out what's this look like on a susceptible hybrid when you have all these different, say you have ideal conditions from R1 through R5. What's the impact once you hit R3? What's the impact once you hit R4?
Right.
Is there a difference in the response to the plant? So that'll be cool to answer. Thinking about this, common secondary problems, obviously healthy leaves require healthy roots require healthy leaves. One of my favorite statements I learned from my crop physiology instructor. What do you commonly see, on these susceptible hybrids? If you have, whether it's 5% leaf severity or 45% leaf severity, what are some common secondary issues and diseases that maybe set in after tar spot kind of lays the foundation?
Right. Yeah, we've seen a lot of things move in. Stalk rots. We have a lot of lodging issues happening. Canopy greenness as the canopy shut down. It just kind of eats away at the inside, and so we just have a lot of lodging and poor plant health.
Yeah, tell me about your research. I know looking at this is some of the newer stuff you're looking at. What I'm trying to remember what I heard you talk about in the past with your research. What have you been looking at the last 3 to 4 years?
Mainly has been that hybrid by fungicide, looking at those impacts. We did that project not only in Indiana but also Illinois, Missouri did it a year, Iowa did it last year, Michigan, Wisconsin, and Ontario. So not just looking at Indiana effects, but also can we broaden it to Midwest?
Do you have any ideas? One of my favorite things to look at is, I remember we had a product that was pretty much resistant to all of the major diseases, northern corn leaf blight, gray leaf spot, and yet it would still have a fungicide response. What's your thoughts on that? If we have a hybrid that's less susceptible, or we'll say even resistant to tar spot,
right? Are
you still seeing any hybrids that maybe still respond to a fungicide application?
Yeah, and what's odd is if you have a hybrid that's susceptible to tar spot, it has a good background for possibly other diseases, but then switching gears, my resistant hybrid would have a really bad northern corn leaf blight. So then you're also looking at different things that might move in.
Yeah. That's weird. I feel like we have so much to learn with fungicides and maybe some of the claimed physiological responses to fungicides, right? I feel like there's a genetic component that we know zero about.
Yes,
with
absolutely.
With fungicides and the hybrid response, but the whole conversation around resistance, and the fitness cost even.
Yes.
I don't think we know a whole lot about that either. So I'll be curious if someone ever digs into that.
Yeah.
When you look at hybrid resistance, and you're comparing that to the susceptible and less susceptible, what do you see for a yield response under severity? Because my response as someone who primarily works in ag inputs is I'm still primarily picking the highest yielding, most suitable fit for the environment, even micro environment, right, like the field. but the industry's catching up with these products now. So how what have you seen from a yield response susceptibility comparison?
Yeah, so the susceptible hybrid that we used was really strong yielding if it wasn't disease ridden, versus the resistant hybrid we used. We did see pretty low yields. Yeah. So yeah, you kind of have that yield trade-off. For I was seeing if we had a lot of disease, maybe they were almost equal, versus if we had less disease, maybe that susceptible pulled out.
Yeah.
So it's definitely
it seems
to
like
consider.
that's the tension, right? Is so I mean the inevitable problem of plant breeding is the trade-off of plant health versus yield conversion, and it seems like that's always a tricky.
Which I'm feeling like the industry as a whole has gotten better at that. You know, looking at some of these products the last, especially this year, man. I mean, even though Southern Rust was a conversation, I still saw products that were pretty tolerant, and I don't know if I'd say fully resistant, but only seeing less than 5% severity on them compared to other hybrids that had 25 to 30. Yeah. And I think I think breeding across the industry has done a really good job of catching up with tar spot tolerance. So is that kind of what you're seeing too? I mean, I would imagine. Yeah. Was it your fourth year? You said.
Yes.
I can imagine the hybrids even 3 to 4 years ago that there was probably some pretty susceptible products.
Yes. Yeah. Definitely. Lately, I think the more resistant hybrids that we've used for different projects, we've seen them catch up a little bit as far as yield goes. But yeah, the initial ones that I was using, they struggled to kind of keep up. Yeah.
Morgan, let's talk about some of your. Research looking at leaf wetness. What have you learned? And I know we had some good conversation with Darcy talking about this. We still think there's that 7-8 hour leaf wetness requirement. What have you learned to maybe dig a little bit deeper into that?
Yeah, so I wanted to set up a trial. It was in the field, so I have other variable conditions versus if I did it in the greenhouse, not so much. Still learning how to get this high enough severity in the greenhouse conditions. But I wanted to see kind of different windows of adding additional moisture if I could kind of influence the disease development. So I either irrigated, and when I say irrigate, I have a sprinkler that would kind of overhead mist in kind of a 30-foot diameter circle. And so I would either mist a couple days, a week, the whole day, either from May to June, July to August, or May to August. So kind of playing with that. We're seeing that it needs kind of a moisture conditions initially and then a dry period, trying to play around with those. Yeah. So I just completed my third year of that project. The first, they all say different things every year. So the first year, those initial wet periods kind of spurred on disease more, versus the second year, it was the entire season. And
the entire season was wet?
Yeah, that was what it spurred on. And then this year, I was still working on the data. But.
Yeah. I'll be curious. I mean, thinking about that, are you starting to get a good feel despite every year being different? Are you starting to get a good feel for? I mean, we'll never know when a spore infects, right? Unless you can inoculate, especially with a disease like tar spot. Are you starting to get a good feel for, again, similar question to Darcy, for like the environmental conditions, when you think the disease will show up,
right? When
you think secondary lesions will show up? Are you starting to get a good feel for moisture, the environment, moisture impact on all that?
Yeah, I just feel like, it really depends on, because like I said, I'm in the field, so I'm outside conditions I can't indicate for. So it kind of depends on what's going on in the environment already and then what I'm adding to it. And that was kind of a concern when I initially started this project. Am I going to do anything? I'm adding moisture, but am I doing enough to actually warrant there's something going on? And so that I am seeing a difference between treatments, and so that does tell me I am doing something going on in those microenvironments. And then I also divided my circle into different sections. So do I have kind of a section difference? So I had 1 year my northern section had more disease versus 1 year it was my west side. So is there some kind of like wind happening situation through, or is my sprinkler just, maybe washing the spores near the sprinkler versus outside is still spurring on
that
disease.
Whole spore washing term that I was not overly familiar with until a few years ago. Do you think that's a thing? I mean, are you starting to think that you can have too much moisture where you're actually washing spores off?
I think it might be possible. I know there's a lot of powdery mildew papers where they've looked at spore washing, so it might be possible.
Yeah, I know that. Yeah, I think it was. I was having a conversation with Tamara, and that was the first time I ever heard that conversation, because I was like, man, I feel like, going back to last year, I feel like we had the prime conditions for tar spot. We were having dewy mornings, and it was raining every 3 to 5 days, and the temperature seemed to be cool, but it was constant rain. And so, but yet incidence and severity was pretty low.
Right. And then last year we had that hurricane barrel go through, and so the parts that we saw that normally get a lot of disease didn't, versus kind of those outskirts that had maybe a couple inches did spur on. So
So thinking
Another
about
question.
Infinitely complex.
very, very complex. I guess I just keep thinking about this whole moisture thing. You know, it's not as simple just because we know the temperature preferences. It's not as simple as just keeping your mister on all day, right? I would imagine there was no increase in severity if doing that. It was
if
all
you're
temperature
outside of the
dependent.
temperature range,
Yeah. I can't think of anything else. I mean, that's some good info. You know, as you continue to learn more about this, I think that's going to be critical because I mean, you think you know everything about tar spot, you know, based on our conversation with Darcy 2 years ago, and not much has changed in terms of the temperature preferences. But I think the more we have all these different and challenging environmental conditions, you know, I think some of these little things that you're continuing to learn on, you know, learn about and build on what Darcy knows. I think that's going to be critical as we have higher level conversations, and all your data is going to help feed, you know, some of this technology too, right?
Absolutely.
You know, as we continue to learn about some of these moisture requirements, leaf wetness requirements, humidity requirements, that's all going to feed all this data that hopefully in 5 years makes these conversations a lot easier.
Right.
The predictability is going to be super important from a management standpoint.
Yeah. So Morgan, I do remember now thinking about, I remember hearing you talk about a 1-pass or 2-pass, and we had some really good conversation with Darcy. What's your thoughts on when, where, why, if we need a 1-pass versus 2-pass, or 2-pass versus 1-pass?
And the project that I used, the tar model application, or the tar spotter, it did for some years recommend 2 applications, and we did see a reduction in disease, but didn't see a yield payoff. So I think the big question is when you initially go in, is your disease ramping up what growth stage you're initially at to then do you warrant a second application? You know, we saw, like she said, in 2021, those 2 applications, if you went in early, did pay for itself, but that might not always be the case. 21 was a crazy year.
I'm convinced it seems like when we talk about 2-pass, it seems like we front load it. And I'm more and more convinced with the conversations that we've had with Darcy and a lot of other people that we're putting our fungicides on too early. We're not putting them on late enough. I know Darcy said that sometimes we miss and we go too late, but my instinct is we need later fungicide applications, not earlier fungicide applications. Yeah. I don't think we're protecting grain fill windows long enough, especially as we've moved these maturities. We just went through a process of evaluating products we're going to use for next year. And it was amazing how many products we talked about between 115 and 120 RMs. And, you know, 10 years ago, that wasn't even a consideration. So those things will be interesting conversations. Morgan, thank you. You know, we really want to express gratitude. And when we have the opportunity to interview people like Darcy and Dan Quinn,
I have one final question, I guess, thinking about it. Yeah. Thinking about both your research projects, what are you hoping to answer next year with both those?
Good one.
I don't know. I feel like the more questions that we ask, the more answers we get, the more questions we have again.
True researcher right there.
So I don't know. I guess we'll just find out.
Yeah, let the environment and data speak for itself.
Yeah, hopefully so.
There you go.
A lot of data to analyze.
Yeah. Well, what we know is that when we have the opportunity to interview Darcy, we know that Darcy doesn't do all that work herself, and you know, all of that information that's so valuable to the field is the byproduct of a lot of people doing really hard work, and you're one of those people. So we greatly appreciate that. Our audience does, and agriculture does. So appreciate you and appreciate you taking the time.
Yeah, thank you. I'm happy to be here.
Well, we're back with Ask a Grad Student.
Ask a Grad Student. We just named it, huh?
We did. I thought long and hard. I had 2 potential titles, and I liked that one. So we're back. So tell us.
You've thought long and hard about anything in your life.
Tell us your name, where you're from, a little bit about yourself, and how you ended up at Purdue.
Okay. So it's nice to be here. My name is Eric Oliva. I come from Honduras, and I come originally from a coffee farm. I'm a coffee grower down there. Yeah.
You might be our first coffee farmer we've had on the podcast.
That's good. That's good to be the first one. So I got an agronomy background. I studied at Bryan University, and then we have good networking, and that's how I came here in 2022 as a visiting scholar with Dr. Dan Quinn, and then I started my master's in 2023, and I finished my master's in the summer, and then I started my PhD.
Oh,
yeah,
nice.
That's how I got to Purdue.
Nice.
Yep.
Well, tell us a little bit. You know, we're here to learn from you and kind of some of the research you're doing, some of the things you've learned, some of the things you're hoping to learn. Tell us about your research, what you've looked at, what you're going to continue to look at.
Okay. So basically, my master research was about short-stature corn hybrids and comparing them with full-stature corn hybrids. So we had mainly two big trials in some of the location of the Purdue Ag Centers. And the first one was playing just comparing short versus full-stature corn hybrids, playing with different seeding rates, and then playing with different nitrogen rates. From that trial, we learned a lot. We're trying to learn as much as we can from short-stature corn hybrids, since it's like a new crop for us, right?
Yeah.
In nitrogen terms, we learned that we don't need to modify our practices or our rates, comparing tall and short-stature hybrids. And with seeding rate, we saw that we can push more in seeding rate. I will say in about 6,000. So if a farmer is planting around 32,000, he can go up to 38,000 with short-stature corn hybrids.
So we have played around with short-statured hybrids commercially, and obviously that's part of what Andrew does.
Yep.
So it's a topic that we both have probably a higher level of familiarity with. If you were with the research you've done, Eric, if you were encouraging a grower to consider a higher population with a short-statured hybrid, how are you thinking about dry fertility in that? So obviously you said nitrogen you can kind of keep the same plan, but that's 6,000 plants and 32,000. That's a pretty big percent increase. So how do you think about the fertility component?
Yeah, so definitely we, in the interactions that we analyzed, and we saw that we just got benefits in higher nitrogen rates when we increase seeding rate.
Sure.
So actually, you can increase nitrogen rates when increasing seeding rates. That's we definitely can do that. And the other thing that is one of the big benefits that short-stature corn hybrids have is the lodging, that it can manage better lodging or we can avoid lodging. So we had one experiment at the Southeast Purdue Agricultural Center that we basically didn't have any lodging on the short-stature corn hybrids, whereas the full-stature corn hybrids they lodge. One of the hybrids lodged more than the other one. And basically because last year in that location they had remnants of the Hurricane Helene. That was most in the south, I think. So they really worked pretty good with the lodging issues.
So you actually lucked out. You were looking at the potential impact on lodging, and you actually lucked out as opposed to most researchers where you're trying to look at something and you don't.
You can't ever get it to happen.
Yeah, and that's I think and that's another thing that I like and that I like working with Dr. Dan Quinn, that we are exposed also to share these research findings with the extension program and with the farmers.
Yeah. You're working with a phenomenal lab and learning from Dan.
Yeah.
Do you have any hypothesis, or have you looked at, or are you going to look at? You looked at nitrogen rates by population. Do you have a theory, or again, maybe you've looked at this, maybe you're gonna on other nutrients? If you're finding that there's a response to population when you have an increase in nitrogen rate, do you think that would hold true, or is that something you're gonna look at with other nutrients?
Yeah, I think that our research is more nitrogen based, right? But we need to also research the other nutrients, how to work with those ones.
Yep.
But I think that it's important. It's important to do that. And then the second project that I didn't talk about, but I can share something, is just in short-stature corn hybrids, just comparing narrow row spacing, 20-inch rows compared to conventionally 30-inch rows. And we saw that, and pushing a lot in populations, and we saw that narrower row spacings can handle better plant establishment and better and higher plant populations as compared to 30-inch row spacings.
Yeah. Did you find a constant response in terms of yield, or was there just an impact on? I mean, thinking about going from 30s to 20s, you can impact plant architecture, some of that stuff. Did you see a consistent yield response, or was that something you didn't see?
Yeah, and especially as we go north, harvesting that light, it's more important. So as we go northern, the row spacing response was better.
Okay.
Yeah.
Okay.
Yeah.
I know one of my favorite quotes was Belo's "Every photon that hits the soil is a photon wasted."
Yeah.
That was one that stood out. That's good. Thinking about 2026, you've looked at a lot of cool stuff. Looking at population, nitrogen by population. What are you hoping to look at and answer in 2026?
Yeah. So there's one big project ongoing with cover crops, short-stature corn hybrids, and full-stature corn hybrids, and then soybeans. Just having that rotation. Planting cover crops with drones and planting with drills. So that's like a big project going with a lot of the labs here, and I will be part of it.
Nice.
And then another big one is nitrogen timing. So another lab saw from trials from previous years, they saw like the roots in short-stature corn hybrids are bigger than full-stature corn hybrids. So we want to learn if the nitrogen timing should change between short and full-stature corn hybrids. And another thing that we can dive into. So now we have the winter to get those protocols set, but another thing that we can look into is the yield components or the nutrients how do they differ in nutrients in short and full stature hybrids. And then another thing that is interesting also, especially what we have been talking of diseases, if short and full stature corn hybrids have different in disease, since the leaves are packed closer.
Yep.
And there's like a different microclimate, and leaves are closer to the ground, especially for those disease that overwinter, and that comes from the ground, also from the soil, up to the plant. So
what's your hypothesis on that?
Yeah, I mean, and you were talking previously that genetics will play a big role there. So I will say the famous phrase that it depends. It depends.
Learning from the best.
Yeah. I thought we were done with our interview with
but
agronomists unwilling to take a stance.
But I mean, since for example,
if only we had a camera on Dan's face right now, that would have been perfect.
But I mean, there's like, it's really important from the genetic side, the resistance that they bring, but since it's closer to the ground and the leaves are more stacked together, you will think that probably that microclimate might be wetter, or there will be more moisture and maybe you get more disease.
Yeah, that's a good point. It's above and beyond just that microclimate, right? It's you got a shorter plant with leaves closer to the ground. So we talked with Darcy. She's now thinking about tar spot as a bottom-up disease. We got gray leaf spot, anthracnose, some of those other diseases. So does that impact again more than just the microclimate? I like the way you're looking at it.
And also, I mean, if you're putting 20% more plants out in that field, you're still going to have. It's not like the plants have less leaves, so you're increasing the leaf space, but you're also decreasing probably airflow. And
shorter leaves plus more of a dense, with the neighbor, dense canopy with the neighbor. Yeah.
Especially if you go to 20-inch rows. I mean, it'd be hard to walk through.
It's actually not fun to walk through on 20-inch rows.
Yeah. It's not fun.
Feels like a workout.
I agree with that.
Are you familiar with working out?
No,
that did not look like anything I've ever seen anybody do at a gym.
No. I can only imagine what our marketing team's going to do with me doing this.
Correct. Yeah.
Working out.
Might want to not turn that one in.
No, this is some cool stuff. I think you're looking at some really cool stuff, and it's things that you think about, again, going from 30s to 20s, but also with the shorter stature corn and looking at the, reduced internodes below the ear leaf, right, and just thinking about the impact of some of those bottom-up diseases. So I think that's good you're looking at that. You touched on this, the yield components, and your lab does a really good job of looking at, the rate and duration of grain fill, kernel weight, some of that stuff. What have you done any of that, or is that something you're building on in 2026?
I did a little bit of that during my master's project, and I will say that one of the hybrids, the short stature hybrids, it was the PR111.
20, that it did had less amount of kernels, but the weight it did compensate, and it's always that trade-off, right?
Yeah.
That determines yield, but it just outstand to me that it had a big difference in yield. Oh, sorry, in kernel weight. And then the other three, the other short stature hybrid and the other full stature hybrids, they were pretty similar. Yeah, in yield components.
Yeah,
Yep.
Interesting.
Yep.
Well, no, this is cool. I look forward to, I would imagine Dan's going to be one of those guys, if he's willing to, that we'll have back on in another year and a half or two. So I look forward to picking your brain again, as your research continues and you get more information. So I appreciate the time and definitely look forward to keeping in touch.
We like to ask intro and exit questions. So my exit question for you would be, we like to have stuff to hold over these guys' heads, so we can tease them on social media and stuff. Do you have any good Dan Quinn anecdotes or funny sayings?
I don't know if I'm allowed to say it. No. I just appreciate working here and having the opportunity to be here. He's has been such a good mentor to me, and I think that it's just hard work. Yep. I don't think that I don't have anything.
I thought it was gonna go. I thought we'd have something we could use.
That's cool.
We'll make Dan leave the room. We'll re-ask the question, see if we can get a real answer out of him.
I enjoy hearing that stuff because from someone that has 100%. Heard people that haven't had the best experience through grad school. Me, coming from someone that had a phenomenal experience in grad school, it's not the norm always, right? Most people do, but there are some that don't have the best experience. And so, hearing you talk about Dan, I think that's, again, just being around people like this, you can sense their enthusiasm and passion, and it's hard just being around them, whether you're a grad student or someone that's just here, like me and Sean learning. It's hard not to get enthusiastic. So it's cool to hear that Dan, and I would have guessed Dan's a good mentor and someone really, really good to be around and learn. So that's cool. I appreciate you for sharing that.
Definitely.
Thanks for your hard work, and thanks for taking time to chat with us today.
No problem. It's a pleasure.
Thank you.
Thank you.